Ma'am, I'm just calling him.
Okay, I think we should start because it has been 6:10. So let's start, no?
Okay, ma'am. Yeah, yeah, ma'am.
Okay, so let me introduce myself. I'm Jyoti Sharma and I'm doing tuition for the course Conservation Geography. And today is the last week, that is the week 13. And today the topic will be geography, environment, and climate change because as we already have covered the conservation geography topic, but I thought that these are the topic that are very important and very relevant to the conservation geography. So we will try to cover forest and climate change means how the forest is being like either it is being deforestation or the reforestation. So like different processes are being going on and how it is like what's the signature of climate change on the forest. So we will try to cover this. The second is Kyoto Protocol. This is the one of the conference that has been held in 1997, and after that like it was a document in which like some countries were binded to reduce the greenhouse gas. So we will talk about this Kyoto Protocol. And third is phytoremediation, means we can just remove different toxic chemicals using the plants. So these are the three different topics. I think these are somewhat unique, and probably you have already heard about this topic, right, Kuldeep?
Yes,
Or if
ma'am.
phytoremediation is maybe new for you, but Kyoto Protocol and forest and climate change, I think you already aware of it, right? Okay. So, can you tell me, like, forests are increasing or decreasing right now in 30 years?
What, ma'am?
Like, what's the trend of the forest? Either they are increasing or decreasing
Uh,
worldwide. What's
Ma'am,
your say?
decreasing.
Uh,
Decrease
but if I say that no, forests are increasing, so what will you
overall,
say? Yes,
overall, all over the world.
yes.
Oh,
Okay. So let me show you. Because we have the satellite data, and we have already 30 years satellite data, and whenever we have that image of the satellite and we are trying to plot the trend graph, then we are seeing that for the each pixel the forest is mostly increasing except some pixels. So if we are talking about the forest or greenness, then we will talk about this leaf area index. This is the this is the indicator of the greenness or vegetation. So whenever I will use the terminology leaf area index or LAI, then it means I'm talking about the greenness. So there was one study in 2016. That study reported that there has been greening worldwide in 30 years. So, and this leaf area index has already been increased by 8% globally. And if you see this graph, so here that green color, mostly in India, China, and in South America as well, we are seeing that there is a increasing trend worldwide for the greening. So, and can I ask, like, if this greening is increasing, so what will happen on this temperature? Either it will increase or decrease. What should be, Kuldeep?
yes, ma'am. What?
My
Actually,
question is, my
yeah,
question is, if vegetation is increasing, then what will happen on the temperature? It will increase or decrease.
ma'am, de- it will decrease.
Temperature will decrease, right?
Yes, ma'am.
Okay. So yes, there is also one study that showed that no doubt temperature is increasing, but the pace, the speed, whatever with which the temperature was increasing, it has been slowed down. Okay. So study reported that first, the greening has been increasing in 30 years. Secondly, uh, Danish, let me. Okay, so we have three topics today: the forest and climate change, Kyoto Protocol, and phytoremediations. And right now we are talking about forest. And in first slide, I only showed that because of the greening, whatever the rate was there to increase in the temperature, it has been slowed down. Okay, so just such thing has been done right now. So and here we can see that global warming was rising and it has been slowed down because of increase in leaf area index, or let's say greeningness, by 0.09 plus minus 0.002 degrees Celsius since 1982. It means because of that greening, because of increment in the forest, temperature is decreasing. But yeah, it is not decreasing, but whatever the rate was, it has been slowed down. Okay, but and here we can see that in the right panel we have temperature that has been decreasing. In the right y-axis we have the leaf area index, means the greenness, and here we can see that greenness is also increasing, means with the increment in the greenness, the temperature is reducing, or the rate has been slowed down. That's why we are talking here about the change in. Okay, here we can see the delta. Then but like there are some places where because of forest, warming can happen in spite of greening. So can you guess like how this can be happen? Like in some place because of forest, cooling is happening, but in some places because of forest, warming is happening. So can you guess why this is happening?
Yes, ma'am.
Why? Yes.
Ma'am, due to forest fire.
Due to forest fire. Okay. Any other guesses? Danish?
Ma'am, maybe the less absorption of CO2 by the plants.
But obviously they will absorb some kind of CO2, and if they are
Yes, ma'am, that
absorbing,
less absorption.
if it is less absorption, still they are absorbing something, and it means like the cooling should be slowed down, but it may not cause the warming effect, right?
Okay, ma'am.
But yes, there are few mechanisms by which we will try to understand how forest can lead to the warming as well. And because like there is some interaction between forest and climate change. Okay, and we have to study or understand the interaction between forest and the climate or the climatic variable. So to understand it, we have two mechanisms. The one is known as biogeophysical mechanism, and the second is biogeochemical mechanism. So I will try to understand you what it is. So here we can see, whenever there is a change in the vegetation, either it can make change in the atmospheric gas composition. For example, as you were giving the example that because of vegetation, carbon get absorbed. Okay, so whatever the atmospheric composition there was, it has been changing. Okay, so whenever this happens, means there is a change in atmospheric gas composition, then this mechanism is known as the biogeochemical mechanism. We also know that some of the forest release volatile compounds, some of the forest or the vegetation may release methane as well. So whenever there is a change in the atmospheric composition because of the change in vegetation, then this kind of mechanism is biogeochemical. Okay, the second mechanism is biogeophysical mechanism. So biogeophysical means whenever there will be change in the forest, the surface of our earth will also change. For example, there was forest once upon a time. Now it has been converted into the cropland or the grassland. Okay, so the surface property has been changed. So whenever there is a change in the surface property due to change in forest, then this will be known as the biogeophysical mechanism. And here, because the change in the surface property, the evapotranspiration, the soil moisture, surface roughness, everything will change. And if you know that these kind of processes, evapotranspiration, soil moisture, these are related to the climate change. Okay, we will learn it in the next slide, how these are related to the climate change. So you have to keep in mind Like because of biogeophysical mechanism, there is a change in the atmospheric composition, and because of biogeophysical mechanism, there is a change in the surface property. Okay, when there is a change in surface property, then the energy that has been transferred from surface to atmosphere, it will also change. And this is all about the energy flux or the momentum or water that leads to the change in the climate. Okay, so this is something, maybe this is something new or very complex for you, but these are the two mechanisms that you have to keep in your mind. Is it clear, Danish?
Yes, ma'am. थोड़ा थोड़ा भी clear है.
Okay, so like I'm repeating it once again. Whenever there is a change in the forest, for example, you are converting the forest land to the cropland, either it will change your atmospheric composition, means it may reduce the CO2, it may increase the oxygen, so such kind of change may happen, or the another change can be happen in the surface property, like the albedo effect may also may become changed. Okay, so these are the two mechanisms. We will see how these kind of mechanism or processes take place. Okay, so right now we have like two things, the biogeophysical and biogeochemical, and whatever was the resultant effect, that will tell you like what will be the effect of this forest on the climate. So we have to understand it in a better way. Then because you know the carbon sequestration, it is very much related to biogeochemical mechanism, because there is a like the storage of carbon dioxide is happening within the forest. Okay, so because of this, there will be the negative forcing. Negative forcing means there will be less radiation, and because of less radiation, there will be there will be the cooling effect. Okay, so this is the you have to keep in mind, like here, because of this biogeochemical mechanism, cooling will happen, but this is very much trickier. Okay, because of this geophysical mechanism, it may be the cooling or it may be the warming. We will see next what happens because of this. So here is that because of the CO2 absorption by the vegetation, it will produce the cooling effect, but the biogeophysical mechanism is complex in nature, and it may increase your temperature or it may also decrease your temperature. So we will see how this happens. Okay, so before that, we have to understand the key terminologies. The first is leaf area index. Leaf area index means how much leaf you have, one above one is below, the another is above, and per area. Okay, for example, you have very dense forest, you have herb, you have shrub, you have the tall trees. Okay, so at a particular 1 meter square area, you may have, let's say, 10 meters square leaf area. Okay, so this is kind of the ratio. So here we can say that it is a measure of leaf surface area per unit leaf area. So whenever we are talking about the greenness or like forest or the vegetation, so the indicator of this vegetation or the greenness is leaf area index. So we will always talk about the leaf area index or the NDVI, if you have heard about it. And because if there is the more leaf area, then the it will create some kind of canopy. Because of that canopy, whenever there is a rainfall, so it will try to modulate it. It will try to modulate the photosynthesis, it will try to modulate the evapotranspiration. So we have the canopy of the leaf, and this like all the factor, the surface factor will dependent upon this leaf area index. So this is the first terminology. The second is surface albedo. You people already know that this is the reflected short wave radiation. Okay, and can you tell me, like, if we have one side we have the forest area and another side we have the cropland. Okay, so of which area we will have the greater albedo? Kuldeep?
That
Danish, can you guess?
Ma'am, crop
Crop.
area.
Crop area will have the greater albedo, right?
Yes, ma'am.
Why?
Ma'am, dense forest will absorb the light.
Absorb the light. And can you relate it with the color as well?
Yeah, darker.
Uh,
Less.
because forest is darker in color, so there will be less albedo, but because it is a cropland, means a very light green color is here. So because of light green, the reflection will be more. Okay. So, and you know that whenever there is a more albedo or more reflection, there will be cooling effect. Okay. And if we have forest that is darker in color because of the less albedo, means there will be more warming effect. So here you can see that whenever, because we are replacing this forest area with the cropland, then it may be happen that the albedo effect may dominate, and because of this albedo effect, the cropping land may induce the cooling as comparison to the forest area that may induce the warming effect because of the color difference. So this is the biophysical mechanism, and this is the only the one variable. We will talk about more variable as well. Then the evapotranspiration. What is evapotranspiration, Tanish?
Ma'am, I know about evaporation and transpiration separately.
Yes, yes.
So
This
I
is
think
this
the
is combined
combination of
one.
both is known as evaporation.
And what is transpiration?
Ma'am, transpiration is the process by which the process of evaporation is carried out from the leaves of the plants.
Yes, so whenever there is a photosynthesis, because of that photosynthesis, they have to release some amount of water vapor. And when the plant is evaporating such kind of water vapor, then it is because it is biological in nature, then we will call it the transpiration. But because if we have the dry soil, or if we have, let's say, vegetation even in a very warming scenario, then there may be the evapotranspiration. So we have the evapotranspiration, transpiration, then this is the evapotranspiration. And you know that because of this evapotranspiration, there is always a cooling effect. Is it? Why? Can you guess something, Kuldeep? Can you guess like why because of evapotranspiration there is a cooling effect?
Ma'am, because of the latent heat.
Yes, because of the latent heat. You are exactly right. And what do you mean by latent heat?
Ma'am, latent heat is the heat uh, that water
Yes.
contains in it within it, and uh, it releases latent heat when it changes its state from
Yes,
gas to.
exactly. So whenever there is a change in phase, so there will be a kind of the latent heat. Okay, will be there. So for example, because it was a liquid water on the surface and it has been transformed into the evaporation, or let's say the water vapor. So liquid has been changed into the vapor stage, and because of this gaseous stage or the vapor stage, some of the energy has been released from the surface. Because due to the change in the phase from liquid to vapor, we have to give some kind of energy. And whenever we are giving some kind of energy, then there will be the deficit of energy on the surface area. So that's why there will be the cooling effect. So you have to keep in mind, whenever we have larger forest means more evapotranspiration. More evapotranspiration means more cooling effect. Okay, but opposite to that, if we have a larger forest area, then there will be less albedo, and if we have a cropland, then there will be the higher albedo, and it will be have the warming effect. So can you see the contrasting statement, like because of the albedo there is a warming effect of the forest, and because of evapotranspiration there is the cooling effect of the forest. So this is what it is, the biogeophysical mechanism. Then the fourth one is surface roughness. Surface roughness means if we have a canopy, then we have a very undulating surface. Undulating surface means there will be a very rapid transfer of energy. So because of that forest, we have the higher surface roughness. Then this is one of the important ratio, that is the Bowman ratio. This is the ratio between sensible heat flux and latent heat flux. So you already talked about the latent heat flux, but what do you mean by sensible heat flux? Can you guess something? This is some kind of science class today, like a little bit of the physics class.
Ma'am, sensible heat is something that we can sense or that we can like know like there is heat, whereas a latent heat is the hidden heat.
So yes, means latent heat is whenever you are like changing the phase. So because of the changing in the phase, the transfer of energy will happen, and such type of energy transfer will known as the latent heat flux. But yes, sensible means you have to sense something. Sense means like if you have a surface, above the surface you have the air. Okay, so whenever this air will touch the surface area, and if surface area is heated, then this air will also get heat up. Okay, so this is kind of the sensible heat flux. Because of this conduction or convection, if you have heard, so because of conduction and convection, such kind of heat get transferred. So this is the sensible heat flux, and Bowman ratio is the ratio for this. And if there is a higher Bowman ratio means there will be a drying condition. And if there is a lower Bowman ratio means a very wet condition. And here we can see that because of latent heat there is a cooling effect, but because of sensible heat there is a warming effect. Okay, so you can relate it with the Bowman ratio. So this is some kind of technical, but this is very important, Bowman ratio. The last one is carbon sequestration. You people already know that carbon, whenever it gets stored either in the ocean or in the biomass or somewhere, means something may act like a sink for this carbon. Then this process is known as the carbon sequestration. So we know that biogeochemical mechanism, because whenever there is increment in the forest area, more carbon dioxide will be absorbed and it will give you the cooling effect. But this biogeophysical feedback is very trickier one or the complex in nature, so we will try to understand it well. So here is the figure. You can take 1 minute or 2 minutes and try to understand it. What does it mean? First I give you the background. Background says that there was a forest. So we have the two compartment. In one compartment we have the tropical forest. In second compartment we have the boreal forest, where there is a snow in a very winter season. Okay, and here we can see that there was a forest and deforestation has been happened, and the area has been converted into either the grassland or the barren land. And here, because of the melting of the ice, this ice has been melted and the area has been exposed. So what will happen in these two conditions? So I gave you 1 minute. Try to understand it. What will happen because of this? Because right now you all are aware of the most of the terminology that I have discussed about. Danish, can you guess something from this?
Ma'am, I'm trying to understand.
Yes, please do understand. Kuldeep, you are also trying to understand it?
Yes, ma'am. I'm not watching cricket.
Okay.
Ma'am, can I
Yes.
try? So, ma'am,
What?
in both these scenarios, the
Uh-huh.
temperature is increasing. There is surplus of heat. Uh,
No, there is also the cooling effect as well. If you see, if you can see in the bold black color, cooling effect as well there is. Danish, did you get something from that picture?
Yes, ma'am.
Okay, so from where should you start?
Uh, start from the top, the warming scenarios.
Okay. If you people are not understanding it's all right for me because it is some kind of complex and like it is very advanced. Uh, it will be better if you start with this tree because there is like all
Okay,
arrows
ma'am.
going upside.
Okay, ma'am. So basically, I'm trying to explain this tropical forest scenario.
Yes.
So from trees, we can see that the cooling effect we are getting.
Hmm.
So from trees, we are getting the latent heat flux, and
Yes.
it's reaching to the cloud provide, and in between it's providing cooling effect, and from there it is like getting something CO2 fertilization effect. I don't know what is it.
Okay. Okay.
So
Okay. Kuldeep wants to say something as well. Yes, Kuldeep.
So, ma'am, because of the trees, there is aerodynamic resistance, which is uh, resistance for air, and latent heat flux. This is something that is creating convectional current, and
Yes.
cloud formation is taking place. So, when
Exactly.
cloud formation is taking place, the cooling effect is also taking place as well. And
Yes.
then backward long wave radiation and albedo is increasing because of cloud.
Yes.
Um, I don't know about CO2 fertilization effect.
Okay. Okay. You people, whatever you people told, it was right. So let me explain it in better way. For example, we had the tropical forest. Okay. Because of that tropical forest, there will be evapotranspiration higher. Okay. Because of that evapotranspiration higher, and I also told that there will be higher surface roughness as well. Because of higher surface roughness, aerodynamic resistance will be less. Means air will allow you to transfer your energy upward. Okay. So because of higher evapotranspiration, latent heat flux will be more because of the changing in the phase. Okay. And whenever there is a higher latent heat flux, means there will be the cooling effect. Okay. So surface cooling will be there because of that latent heat flux. This is the one arrow. The second arrow, we can see that because of this latent heat, somewhere in the higher atmosphere, there will be the condensation. Because of that condensation, cloud will be formed. Okay, and this cloud have a very ambiguous role. At the one side, there will be, because cloud acts as a higher reflector. Because of that reflection, albedo will also be larger, and because of that larger albedo, this will also give you the cooling effect. But this is the one side. But another side, we also know that because there is a water vapor, and water vapor is a potent greenhouse gas, and because of that greenhouse gas, the backward long wave radiation will be more. Okay, because it is a greenhouse gas, and because there is a long wave radiation that is larger in that area, this will give you the warming effect. Okay, so it means this type of tropical forest can give you the cooling effect and can also give you the warming effect because of that cloud and the latent heat flux. So this was the one. Okay, so it is like a two-sided effect, the cooling effect as well as the warming effect. Okay, so here we can see that if there is like something happened and this forest area has been converted into the barren land, or let's say the grassland, then because of because there will be less latent heat flux. Evapotranspiration will be less, and because of that, latent heat flux will be less, but the sensible heat flux will be more. Because of more sensible heat flux, there will be no cloud above this kind of cropland, because there is no such water. Okay, because of that, cloud formation will be less, and because of less cloud formation, again, it may give you the cooling effect, because because there is a less greenhouse gas effect, but it may also give you the warming effect, because it has a very less albedo because of less cloud formation. So here you can see that it's very complex, like either the forest area or this cropland will give you the cooling or warming effect. That's why I'm saying that it will depend on the whatever the resultant effect it will give you. Okay, and if we see here the carbon dioxide fertilization effect, this is nothing but whenever there is a more CO2 in the atmosphere, then the absorption of CO2 by the plant has been increased. Because of more CO2, more photosynthesis will happen. Because of more photosynthesis, oxygen will be released. Okay, and because of also that, forest area will also increase, because the CO2 is increasing, and CO2 will act like a fertilizer effect. Okay, so this is something CO2 fertilization effect. Then because of that warming or because of increase in the CO2, there may be the condition that plant stress may be there, because there is no sufficient water is there. Okay, so because of that, plant stress may happen. So this is the case of the tropical forest. But here if we can see the boreal forest, means at the higher latitudes, there is a snow, and whenever the snow is melting, then a bare soil will be exposed, and because of that soil, methane will increase. If methane will increase, it is again the greenhouse gas effect. Then this will also give you the warming effect. Secondly, because if there is a no snow, then forest will increase. Okay, and if forest will increase, it may give you the cooling effect. Means at the one position, whenever there is a melting of snow, it can increase your forest area, cooling effect can be happen. But at the other side, methane will may increase, and because of increasing in the methane, your warming effect may be happen. So this is kind of the complex system. So you have to understand, like in which area which process is dominating one. So here we can see, like in tropical forest, evapotranspiration will dominate, but in the boreal forest, albedo will dominate. And because of that, in the tropical area, albedo will have a very negligible effect. But because of evapotranspiration, more forest area will give you the more cooling effect. But in the boreal forest, because evapotranspiration is not that much dominating, albedo effect will be more prominent. And because of that, if we are doing the deforestation, then with the deforestation, cooling effect may also happen. So this is kind of trickier and complex one, but yes, this will give you the resultant cooling or the warming effect. So I think it is something new for you. Is it, Tanish, Kuldeep?
Yes, ma'am.
Okay. So here we can see that it is very complicated in nature, and we have to understand it if we want to understand whatever the linkages we have between forest and the climate. Okay. So okay, this is again the one slide that will give you the biogeophysical feedback. So here we can see, like we have four different type of surface. The first surface is ENF, that is evergreen needle forest. DBF means broadleaf forest, deciduous broadleaf forest. CRO means cropland, and GRA means grassland. So here again we can see that this blue color arrow is more in the forest area, means the latent heat will be more in that area, and because of that, cooling effect will also there, and because of this latent heat, more cloud will be formed here. But sensible heat is just opposite to the latent heat flux, so it will be less wherever there is a higher latent heat flux. Then if we see the reflected light, because we know that albedo is dependent on the color. So if we have like evergreen needle forest or deciduous broadleaf forest, so these kind of forests are greener in color, so it will give you a very less reflected light. But if we have the cropland and grassland, the reflected light will be more, and because of that it may give you the cooling effect. Okay, so whenever you are talking about the forest feedback on the vegetation, then you have to keep in mind background climate will also be a very determining factor for that. The geographical location, either your forest is in the tropical area or it is in the higher latitude, so this will also give you some kind of knowledge to understand you the effect of this forest on the climate. Then you also have to keep in mind what type of forest you are talking about, either is this tropical in forest, or either it is boreal, or let's say it's deciduous. So you have to keep in mind what type of forest you are talking about. Then such effect, like such effect of the forest, these are very local in nature. Means like the effect is only up to few kilometer. It may not change your atmospheric circulations. So this is very regionally or locally in effect. And this is somewhat I already have taught you. Okay, the second one important topic that today I want to cover is the Kyoto Protocol. Have you heard about it, Danish Kuldeep? Kyoto
Yes,
Protocol.
Yes, ma'am.
ma'am.
Okay, so what it is?
Ma'am, a kind of convection to reducing the carbon emission globally.
Okay, so how much percentage of greenhouse gas was targeted to reduce? How much percentage, if you know?
Ma'am,
Ma'am, net zero.
5.2%.
Yes, approximately 5%. And you people know that there were two different type of country, Annex 1 and Annex 2. Do you know what does it mean? Okay.
Yes, ma'am. Ma'am,
Okay.
Annex 1 countries targets were set for commitment for the period of 2008 to 2012, and
Okay.
Annex 2 country, the convention held in Doha, known as like Doha Convention in
Okay.
Qatar, and it committed for the second period from 2013 to 2020.
If I say that Annex 1 countries are the developed countries, these country had due to this Kyoto Protocol, these country had the legal binding to reduce the greenhouse gas. But if we are talking about the Annex 2 countries, these are just like the developing countries as India. So we didn't have any legal binding to reduce the carbon dioxide, or let's say the greenhouse gases. So these were two different of the countries. So we will talk about it. From this picture, what you can observe?
Ma'am, it is some type of, we can say, a geopolitical scenario in
Uh-huh.
which the developed nation is like saying we must all do something. And when we see, say, we mean you. It means when we see like we have to reduce carbon emissions, then it will be the developing nations, who will reduce the carbon emission. Like we are the developed ones, we are superior than you, so we are not going to reduce it. You people are going to reduce it, and like do not develop yourself further.
Yes, yes, Kuldeep.
Yes, ma'am. Actually, the developing countries are not bound to reduce like the developed countries. So they are not allowed to use a lot of carbon content or carbon. They cannot emit carbon too much. Like developing countries can emit carbon dioxide, to become developed first. So actually, developing countries like China, India, and
Mhm.
other countries are emitting carbon more than some European countries that are developed
Yes.
because they are
So
already developed.
yes, exactly. So if we are talking about the emission, then yes, our developing countries such as India, China are releasing a greater amount or the greater concentration of greenhouse gas as comparison to the developed country. But yes, if we will talk about the per capita per person, then our emission rate is very less as comparison to the developed country. But developed countries are saying that because your emission is that much higher at this time, so you must stop it. But uh, but somehow if we see very political this kind of statement, then we will see that yes, there is a still the development is yet to be done in the developing country, and because of that development we have to release the greenhouse gas for that. Okay, so we can't stop at the rate that they are saying, and they are such like they are forcing that you have to stop it at a very greater pace, so we can't do it. And this is something like that Danish rightly said that yes, because whenever they are saying that yes, we have to reduce the greenhouse gas, but they are just focusing on the developing countries. Okay, developing countries must reduce the greenhouse gas. Okay, so this is kind of a monopoly of the developing country over the developing countries. Yes. Okay, so here if we can see the percentage change. Yes, Danish.
Ma'am, or if we can say that the carbon emissions or the greenhouse gases are increased just because of the development in the developed countries, and now they are saying that you are not entitled to emit so much of emissions to develop yourself. This is like something hypocrisy they are
Yes,
doing.
yes, this is happening that over this 100 or 200 years, there has been released a lot of energy, a lot of carbon dioxide that we can't manage it right now in a very proper way. But right now they started to reduce it. But this is the time that developing countries started to release it at the higher pace, and this is the time when they are saying that yes, you should stop it. So yes, there is a like a very contrasting scenario. Okay, so here in this picture what you can see, this is the percentage change of the CO2, and at the right axis we have a year. So what is happening? CO2 emission by the Annex 1 countries are increasing approximately, except few countries, for example, Germany, Japan, or this green color European countries. So, except some few countries that are developed in nature, most of the countries still releasing CO2 in the atmosphere. Mm, okay, so let me define the Kyoto Protocol. So this is kind of the international treaty that extends the 1992 UNFCCC that commits state parties to reduce greenhouse gas emission. And this was the first time that developed countries were forced to reduce the greenhouse gases. So the Kyoto Protocol was adopted in the Kyoto. Kyoto is a city in Japan in 11th December 1997. So may you know that what was the first where was the first COP, means Conference of Party, was organized? Do you know the COP, Conference of
No,
Parties?
ma'am.
Okay,
Never heard
so
about.
okay, so what happens that in 1992, like there was a kind of organization that was formed. That organization was UNFCCC. Okay, because of that UNFCCC, there was kind of consensus that we must reduce the climate change. And if you know the IPCC, do you know the the full form of IPCC? Intergovernmental.
Yes,
Yes.
control on panel, sorry,
Yes,
intergovernmental panel on
panel on climate
climate.
change. Yes. So because what IPCC does, it releases some kind of reports, and in that report, it tells like in how much country, in how much year the country will reach that much concentration of the CO2, or that much concentrate, like what kind of temperature warming will be happen. Let's say in 50 year next, or let's say in 100 year next. Okay, so such kind of information IPCC produces. Okay, so what happened in 1992? IPCC and this UNFCCC organized a conference, organized a treaty in which they told that every year we will, like there will be a kind of conference, and in that conference the political parties or the political government will come together and will work on the climate change. Okay, so these were the conference of party, means every year there is a conference of parties. Parties means the UN countries and the uh, leader of the UN countries. For example, every year our PM or some secretary uh, uh, goes in that country wherever there is a conference. So these are the conference of parties. So it started in 1995 in Berlin. So first COP was in 1995, and right now I think it's COP 28, and it will happen in Dubai next, I think next year or in next month, I don't know. So it was like there was also some COP, I think it was 10th, nahi, it was 5th or 6th COP that in which this Kyoto Protocol was adopted. So this is the COP, means Conference of Parties. So um, here the Kyoto Protocol was adapted in 1997, and it came into force in 2005. And 192 parties, matlab 192 countries ratify this protocol. Okay. Then okay, so we have the annex one country and non-annex countries. So annex one means the developed countries, and these developed country were given a target, like you have to reduce 5% below 1990 level. Means whatever the greenhouse gases emission you had before 1990, you have to reduce the 5% of it. Okay, so this was the target. And if we talk about the non-annex one, so these are the developing countries. So they didn't have any kind of obligation to reduce the greenhouse gas emission. So here we can see that these orange color countries are the annexed one countries, and these green color countries are non-annexed countries. So these are the developed one, and these are the developing countries. Okay, and here this protocol was based on the principle. That principle was common but the differentiated responsibilities. So can you guess what does it mean by like common but differentiated responsibilities? Danish?
Ma'am, could you please repeat?
What does it mean by like common but differentiated responsibilities?
Ma'am, it refers like common means like it is a worldwide problem. We
Yes.
all have to like resolve it commonly, and we have differentiated responsibilities because in a particular country we have very different types of scenarios in regarding to the greenhouse gases emissions. So we have a common goal to reduce the greenhouse gases emission, but we have different responsibilities in combating these types of like problems.
Yes. So it was like that. Yes, it is a common responsibility that we have to reduce the greenhouse gas, but it is a differentiated as well, because the developed countries has already released so much greenhouse gas that the responsibility of developed nations are more as comparison to the developing nations. Means the responsibility is different for the developed country and as well as for the developing countries. Means because you have released more greenhouse gases earlier, then it's your responsibility, it's your more responsibility to reduce it. Obviously, India as a developing country will try to reduce it, but at the same time, you are legally binding as a developed country to reduce the greenhouse gas. So there is a differentiation in the responsibility. India is not legally binding, but the developed countries are the legally binding, that they have to do it somehow. But India can try to reduce it. So this is kind of the common. Yes, this is a common issue. You have to reduce the greenhouse, but responsibility may vary. Okay. So this was the principle for the Kyoto Protocol as well. That's why the legal binding were on the developed country, but for example, for China and for India, it was not the legally binding challenge. Okay, so it acknowledges that individual country have different capabilities in combating climate change, owing to the economic development, and therefore puts the obligation to reduce current emission on developed country on the basis that they have historically responsible for the current level of greenhouse gases in the atmosphere. And the second thing is also that because this developed country has a very advanced technology with them. Okay, so because of that advanced technology, they may reduce this greenhouse gas very efficiently in and in less amount, because the technology is very efficient in nature. So because they are advanced in the technology, because they have released already so much greenhouse gases, so this is their responsibility more as comparison to the developing countries, that they reduce the greenhouse gases. Okay. So there were some principal concept of this Kyoto Protocol. The first was, it was first time it was legally binding commitment to reduce the emission of greenhouse gases for the Annex 1 parties. Okay. Secondly, implementation. So if we want to meet the objective of this protocol, then we have to implement. We have to take some kind of measures. We have to list out the problems. We have how in like we must have the mechanism how we can reduce it. Okay. Then for the developing country, they also release the adaptation fund for the climate change. So because of that IPCC, because of that UNFCCC, the developing country also receives some kind of monies to reduce the climate change. Okay. And then accounting, reporting, and reviewing, all these are the like different processes that have to consider while implementing such kind of protocols, such as the Kyoto Protocol. Then okay, so this is the chronology I was talking about. So in 1992, United Nations Conference of Environment and Development was held in Rio de Janeiro, and this also resulted in the formation of UNFCCC. Okay, so in 1995, the UNFCCC meet in the Berlin, and this is also known as the first conference of parties. The first conference of party was held in Berlin to outline the specific target on the emission. What should be the target for different countries? Okay. Then in 1997, this party concluded the Kyoto Protocol in Kyoto, Japan, and they also agreed to the broad outline of the emission targets. Then 2004, Russia and Canada rectified the Kyoto Protocol because they were against it, because they were the developed country and they were denying for such kind of bindings. Okay, so there was a time that they also announced their withdrawal as well. So in 2011, Canada became the first signatory to announce its withdrawal from the Kyoto Protocol because it was binding in nature. Okay, so in 2012, the first commitment periods under this protocol expired. Okay, so here the target was we have to give a level, we have to reduce our greenhouse gas at such a level where the dangerous anthropogenic interference can be reduced. Okay, and we have a different mechanism under this Kyoto Protocol, so we will talk about this mechanism as well. Okay, so there were three gases that were tried to reduce. So carbon dioxide, methane, nitrous oxide, hydrofluorocarbon, perfluorocarbon, and the sulfur hexafluoride. So these were the gases that were tried to reduce in this under this Kyoto Protocol. Okay, so you were talking about Doha Amendment as well. So the first protocol, first commitment period started in 2018 and ended in 2012, and the second period commitment was agreed in 2012. This is also known as the Doha Amendment to the Kyoto Protocol, in which 37 countries had the binding targets. Okay, and this is not that much important for you. Okay, so we had different mechanism by which we can reduce our greenhouse gas emissions, and these mechanism were mainly trading mechanism, uh, um, a CDM, if you have heard about it, and the joint implementation. So what do you mean by it? Here we have the clean development mechanism, we have the joint implementation, and we have the international emission trading. So have you people heard about these three terminologies earlier? Kuldeep, Danish?
Um, Ma'am, I've heard about the clean development mechanism and joint implementation.
So do you know what it is mean?
Ma'am, I've only heard these names. I don't know about.
Okay, okay. So we will talk about these three mechanism. So okay. So in that mechanism, we assumed that carbon is just like a commodity or like an object that we can say sell or we can buy as well. So for example, there is a one country that is releasing carbon dioxide in higher amount, but at the same time, one country is releasing the emission that is less as comparison to the cap. For example, there is a one country A, and the legal binding is that you can release, let's say, 20 ton of carbon dioxide every year. Okay, so this is the cap of the emission, but one country release 25 ton of carbon, and another country releases, let's say, 15 ton of carbon dioxide, and emission was the 20 ton of carbon dioxide. So what this country A can do, this country can buy the carbon from country B. Okay, because B country emitted a very less amount of carbon as comparison to the cap, whatever it was. So like they can trade the carbon. That's why carbon is just like the commodity. Okay, so we have different type of like we will talk about these units in next slide. Okay, so we had three mechanism. The first is carbon trading, sorry, emission trading. The second is clean development mechanism, and third is joint implementation. So we will talk about it one by one. Okay, so here we can see the emission trading. So for example, there was a country, and here you can see the cap. Cap means in this cap you can release the carbon dioxide, but if you are above and if you are exceeding that cap, then you have to pay the penalty for that. But here the another country is well within this cap. Okay, so this is well within this cap, and this is like exceeding the cap. So here we have the excess emissions. They are emitting more greenhouse gases, and these are they have the unused allowance. Whatever the greenhouse gas emission was there that were allowed for them, it has been unused. Okay, here we have the unused allowance, and here we have the excess emission. So they can trade in the money, this emission or this carbon. So this is the emission trading. And because this is some kind of, this is for the annex 1 countries only. These two countries should be developed only. Okay, if India has a cap, India literally doesn't have any cap, because it is not legally binding for that. Only cap is for the developed country. So let's say if it is a Germany, and if it is a USA, and USA is releasing more greenhouse gases as per whatever the cap was, so it can trade with the Germany, and this USA can give some money to the Germany, so that whatever the target was for the emission, it can be within the cap. So this is the emission trading. So this is the mechanism that enables country with legally bind emission targets to buy and sell emission allowance among themselves. Okay, so each country have a certain number of emission allowance, the amount of carbon dioxide that it can emit in the line with the Kyoto reduction targets, and this allow the industrialized country to trade their surplus credit on the international carbon credit market. For example, Germany is emitting very less carbon dioxide. So what Germany can do, it can sell this carbon credit in the international carbon trading market, so that this country can have more money for the next task. Okay, so this is the international emission trading. Here, this is another picture that is showing you the same thing. Here we have the unused permit. Here we have the excess of emission, and so the company 1 and company 2, like company A can sell and company B can buy. So such kind of mechanism of trading the carbon has been adopted under this Kyoto Protocol. Okay, the second is clean development mechanism. So if we were talking about the emission trading, that it was between developed country. Okay, but this clean development mechanism is between developed and developing country. For example, India doesn't have a good technology to cope up with the climate change, to cope up with the reduction of this greenhouse gases. So the developing country may invest in the developing country, so that the greenhouse gases can be reduced in the developing country. So how much amount of this greenhouse gas will be emitted from this developing country, it will be credited to the developed country. So this is the clean development mechanism. So here credit may be generated from emission reduction project, or from afforestation and reforestation project in non-annex 1 country. For example, if USA comes in India and says that we will increase your forest area, and because of that forest area, the carbon will be stored, and because of that carbon stored, they will get some kind of credit. Okay, so this is kind of the clean development mechanism. So it is designed to provide developed countries with flexibility to meet greenhouse gas emission reduction target that they agreed to achieve under the protocol. Means they can work in the developing country to achieve their targets. Okay. So here developed country may finance greenhouse gas emission reducing projects undertaken in the developing countries and receive credit to help them to meet their mandatory limits. So this is what do you mean by clean development mechanism. Yes, here you can see that, for example, India, this is the India emission. Okay, this is the India emission. And for example, if developed country uh, uh, does some kind of investment in India so that our emission has been reduced with that much. So that much, that light blue color, here we can see that here emission has been reduced for the India. So how much carbon has been reduced, how much emission has been reduced, so this will be credited to the investing country or the developed country. So this is the clean development mechanism. This is again the same. This is again the same. Okay, the joint implementing. So what happened, this is also this is among the developed and developed country. For example, in one developed country there is a lack of technology, for example. So with the technology, this developed country can invest into another developed country in such a way that it can reduce or it can sequestrate the carbon dioxide in another developed country. So in that way also, the first country may get the credited. Okay, so these are the three mechanism. The first was the carbon trading, the second was the joint CBD, the clean development mechanism, and third is joint implementation. So do you have any doubt, Danish, for that three mechanisms?
No, ma'am.
Okay, so can we proceed further? Okay, so here, can you tell me which mechanism is this under A and which mechanism is under B? Here we have Germany, that is developed country. China is the developing country. So which kind? Yes, yes, Kalyan.
Ma'am, China is, yeah, China is developing and Germany is developed country.
Yes,
So this this is a trade. This is the second trade, that is
clean development
clean,
mechanism.
yeah. And
Yes,
the second one is the first trade. What was the name?
International emission reduction or the trading, international emission trading.
Yes, ma'am. Yes,
Okay,
ma'am.
yes, yes, you are right. Okay, so but this Kyoto Protocol has some kind of disadvantage as well as the advantages. So what are these? If we talk about the advantages, then the preservation of mankind future maybe happen because we are creating some kind of target that that should be completed. Then there is open doors for the innovation as well. The innovation, the technology through which we can reduce our greenhouse gas emission. Okay, so this is kind of open door for the innovation. Then we can also ensure survival of the future generation. But there is some disadvantage as well. So what type of disadvantage we have? The one important disadvantage we can get from this Kyoto Protocol. Can you tell me, Kuldeep, Danish?
Yes, ma'am.
Yes.
Ma'am, so those countries that are wealthy or rich, so they can further emit carbon as
Ah,
long as they have money to trade the carbon footprints with a developing or another country like US. So US
yes.
will keep developing even more, and it will buy the credit from other countries, like it will buy from any African country that is developing.
Yes, exactly. And second is that if you see here, I have one picture. Here we can see that we have some kind of emission cap as well. Okay, it means that you can emit that much carbon dioxide. And this is kind of something that should not be. Because like we are free to release that much and that much carbon dioxide. Okay, and this should not be like this. Because like we should not get advantage of this, because Kyoto Protocol is giving you something in hand that you can emit that much carbon dioxide. So this may be also bad for us. Okay, So it requires more participation, and this is not the big issue. We can utilize more participation, though it only requires wealthy nation to cut emission. Yes, we agree that developing countries must have some kind of legal binding as well. It may be like 1%, 2%, 3%, but there should also be the legal binding for the developing countries. It should not like be that for the developed country we have that target, but not for the developing country. Poor implementation is also going on because somewhere such as Russia or Canada that withdrew themselves from such kind of protocol. Okay, so here we can like there is some cases where there is a poor implementation also, that it comes with the bigger challenges. Uh, Government and authorities have to draft rules and regulation to ensure the compliances, and bigger question would be what constitute compliance and violation. So what will happen, like what will be the penalty for the violation, but what do you mean by the compliance? So such kind of rules and regulation they have to draft in a very efficient manner. So it is a kind of task we have right now. What type of rules and regulations we must have in our developing countries so that we can reduce the greenhouse gas emissions. Okay, so there are also some pros and cons of the carbon trading. So pros are there is a reduction in greenhouse gas emission, and there is also this is kind of revenue for the developing nation as well, because the developed countries can come and invest in the developing countries, and here we can go for the green technology as well, and this is good for us. Then if we talk about the cons, then they are giving the right to pollute as well. As I already told you that there is a some kind of cap. Within that cap we can emit the CO2. Okay, so they are giving us the right to pollute as well. This is very slow process, lack of centralized system or the global network, and no efficient carbon reduction. Okay, so this is some kind of delimitations we have for the carbon trading. Okay, so there are also some companies that are doing such kind of work, the carbon trading. So in India, for example, that uh, that we had this Delhi Metro Rail Corporation. So while we were constructing that Delhi Metro Rail Corporation, railways and the railway stations, so at that time we also earned the carbon credits, because we were using a very advanced technology so that we can reduce the electricity for the transportation. We are also reducing the carbon dioxide, because the metro is very clean in nature. Okay, so such kind of companies may get credit of the carbons, and here we also have some companies as well. So here we have the Suzlon Energy and the Shri Ram EPC company that works in the wind energy, and this company was eligible for the carbon credit benefit. Okay, then there is a company Gujarat Fluorochemical that was also company that registered for the clean development mechanism. Means they are inviting the developed country to come and invest in our company so that you can get the credit, and in turn we can get a very well and very advanced technology from the developed country. So this is kind of the win-win situation. So many of the companies in India are registering themselves for this clean development mechanism. This is not that much important for you. This is not important. Okay. The third topic, that is the phytoremediation. So what do you mean by it? Have you heard about this phytoremediation earlier? Kuldeep, Danish?
Ma'am, you told about it.
Yes. So what it is?
Ma'am, you told about it today earlier in this class. Um,
Mhm.
I cannot recall actually.
Okay. Phyto means plant. Remediation, so you can guess something about the phytoremediation. Phyto means plant. Remediation means to remediate something, to correct something. So phytoremediation is something that is related to plants and how this plant may help us to remediate something. So means if we, let's say in the soil we have we have toxic chemicals. If we have the selenium, if we have, let's say, uranium in our soil because of, let's say, the nuclear blast, so we want to remove that chemicals from our soil. So how we can do it? For and the second example is because we have air pollution in our cities. So we have carbon dioxide, we have nitrogen oxide, we have sulfur dioxide in our atmosphere. So plant may also help to absorb such kind of chemicals. Okay, so this is the remediation with the plants. So this is the phytoremediation. Okay, so this is very efficient, and I will tell you something about this. Okay, so we have 5 mechanisms for that. These terms may be very peculiar or strange for you, but you have to digest it. Uh, Phyto means plant. Everywhere you will see the phyto, and rhizo means root. Okay, so phyto extraction, phyto volatilization, phyto degradation, rhizo degradation, rhizo filtration, and this is what? Phytostabilization. Okay, so we will talk about it one by one, but yes. Okay, so what you can see that, for example, you have one pollutant. This is red in color in left hand side. If you can see, this pollutant may be stabilized in the root area. Okay, so for example, if you had nitrogen dioxide, this is pollutant. But what plant can do? Plant can do the nitrogen fixation. It can convert it into either ammonia, or let's say nitrate or nitrite, or maybe N2. And this is inert in nature. It means this pollutant can be converted into a very stabilized chemical or stabilized gas. So this is the stabilization by the plants. So this is phytostabilization. Then phytostimulation. What do you mean by phytostimulation? It is also like the phytostabilization, in which we have some kind of enzymes that can stimulate it and that can also convert it into different type of chemicals. So this is phytostimulations. Then we have phytoextraction. So what happened in phytoextraction means it plant can absorb some kind of chemicals. So this is phytoextraction. Phytovolatilization means it can release some kind of chemical in the atmosphere, and it may change the chemical property of the pollutant. So this is phytovolatilization. Degradation means it can degrade it, break down into some smaller molecules. So this is the phytodegradation. And rhizofiltration means if we have roots in the water, so whatever the pollutant there was within the water, so it can be absorbed by the root, and it can remove this kind of pollutant from that area. So this is the rhizofiltration. So this much use we have of a single plant, but the capacity of plant is different. Like one plant may have different characteristics as comparison to the another plant. So can you give me some name of the plants that are on our roadside? Because most of the roadside plant have this kind of characteristics we have. So can you give the name of one plant that you can get in the roadside?
Ma'am, Ashoka tree.
Ashoka tree. Ashoka tree is very good for the noise absorption. Another one?
Ma'am, there are lots of plants in our university. Ashoka tree, banyan tree, peepal tree, neem tree,
Yes,
mango tree, and we
man.
have long trees having leaves like uh, coconut tree. I don't know what.
Okay, so you people already know about some of the name, but uh, have you heard about that Pila Kaner as well? Pili Kaner, that pink Kaner as well. So such kind of plants we have that have a very higher rate of this phytoremediation. So we will talk
Ma'am,
about,
is
yes,
that their leaves are yellow and pink?
not yellow and pink, but their flowers are yellow in color.
Okay, we have a tree here. It's uh, the whole tree is pink, like cherry blossom tree.
Oh, I don't know about that tree, but yes,
Ma'am,
there are lots of tree and lots of benefit we get. Yes, Kuldeep,
ma'am, we have another tree that is completely yellow.
completely
Yes,
yellow.
ma'am. We have these two distinctive tree in our
Rare trees.
university that
So,
is completely yellow and completely pink.
so these trees are like flowers are yellow and pink, but or the leaf of that trees are yellow
Ma'am,
and pink.
leaves are yellow and pink.
Okay, you can send me the picture. I can tell you the name if I know.
Okay, ma'am.
Okay, so
Sure, ma'am.
these are the benefit then that we can get from one tree. Like it can do the phytostabilization, rhizofiltration, stimulation, extraction, volatilization, and the degradation as well. So such kind of things we can get from a single tree. That's why, like most of the trees, we are trying to select. Uh, according to their property, and we can grow it in a very pollutant area. For example, like there is also some kind of strategy. For example, if there was a mining area once upon a time, and at that mining area now we want to make the soil very fertile right now. So what kind of tree we must grow there? So this dependent on what type of process or what type of mechanism the tree have. Okay, a tree should be very resistant to the chemical. Tree should be the absorbent for such kind of chemicals. So such kind of things we have to keep in mind while growing trees on the barren land or on the mining areas. So based on that we can select our tree. Okay, uh, okay, so if we are talking about the phytoextraction, extraction means there was some chemical in the soil, and this chemical may be absorbed by the root, and this may can get accumulated in the leaf area. Okay, so leaf may accumulate the dangerous or the toxic chemical in their leaf itself. So this kind of process is known as the phytoextraction. So if I read that, plant roots uptake metal contaminants from the soil and translocate them to their above soil tissues. Means they can get accumulated in the stem. They can get accumulated in the leaf area as well. So once the plant have grown and absorbed the metal pollutant, they can be harvested and disposed of safely. Okay, so in such a way, the pollutant or the contaminants we have in the soil, we can extract it out using the plants. So this is the, and we have to select higher accumulator plants. Like some plants have the higher capacity to accumulate the toxic or the contaminants. Okay, and some plants may have a very low capacity to accumulate such kind of toxic chemicals within their body. Okay, so we have to select some species. For example, if we have the Avena species or the Brassica is the species related to the mustard. Okay, so such kind of species have a very higher capacity for these phytoextractions. Okay, and the metal compounds such as zinc, copper, nickel, these can be phyto extracted from such kind of trees and from the soil. If we are talking about the rhizofiltration, so in the water we had some chemicals, and these chemicals again we may filter we may filter the water using the plants. Okay, so here we can see that plant is under the water. For example, we have the mangrove forest, or for example we have the plants that can be grown in the water itself. Okay, so such kind of plant may absorb the chemical from the water and may purify this water. That's why this is known as the rhizofiltration. So this is concerned with the remediation of the contaminated groundwater, and the contaminants are either absorbed onto the root surface or are absorbed by the plant roots. So this is kind of condition is under this rhizofiltration. There are also like we have the mangrove plants, and we have different type of plants we have through which we can do this phyto extraction or the rhizofiltration. Okay, then the phytostabilization means we are stabilizing our chemical. For example, as I already told you that we had the we had let's say the nitrogen dioxide. This nitrogen dioxide is very toxic in nature, but we can stabilize it in the form of, let's say, N2, that is nitrogen, or maybe in ammonia, maybe in nitrates or the nitrites. So this is kind of the phytostabilization, and this can be happened with the help of the trees. Okay, so then the phytodegradation. Degradation is, it is breaking down the complex compounds in a very simpler form. Okay, and here we have some plant enzymes we have within the plant and near the roots that can decompose and that can like break down such complex compound into a very simpler one. So this is phytodegradation. Then the rhizodegradation, this is like with the roots, you can degrade, you can do the degradation. Then photovolatilization means if there is some kind of chemical in the soil, so this chemical can be absorbed by the plant, and this chemical later can be released into the atmosphere because of the volatility of the chemical. So this is the phyto volatilization. I think this was very short lecture today. So this much was about this lecture. If you have any doubt, you can ask me. Otherwise, we can. Is it clear, Kuldeep, Danish? Like phytoremediation, the Kyoto Protocol, and the role of forest and its signature on the climate change.
Yes, ma'am. Yes,